All right, today we're going to look at probability when you are doing multiple trials of something or where you're combining things together. Uh, in this first example, it says to find the probability of spinning a purple and then spinning a blue, you need to find the probabilities of both events occurring separately. Spinning a purple, then spinning blue are what's called independent events. We've talked about this before because spinning one spinner has no effect on the second spinner. They're two separate things. So for this first one, we can see on spinner 1 here that the chances of spinning a purple are 1. There's one successful purple spot right here out of 6 evenly spaced items. So probability for first spinner would be 1 out of 6. On the second one, probability of spinning a blue, we can see there's 3 out of 4 of those evenly spaced chunks on the spinner. That would be the same, so this would be 3 out of 4. Okay, so now let's look at if we combine these together. If they are independent events, which means they have no impact on the other, and you want to find the probability of doing them, you got to take their separate probabilities, which again we had 1 out of 6 and 3 out of 4. If you want to find the probability that two events happen both A and B, and they're independent, then the probability of both events occurring would be the multiplication of both. So anytime you're doing and, you want to find the probability of something and something else, this would indicate that you want to multiply. So if we're spinning these two spinners and we want, what's the chances of spinning a purple on the first spinner, which is 1 out of 6, and spinning a blue on the other, which is 3 out of 4, we want to multiply those two probabilities together. Now remember, when you're multiplying fractions, you want to multiply straight across the numerator and straight across the denominator. So this would be the same as 1 times 3 is 3, 6 times 4 is 24. So the probability is 3 out of 24. Or if you simplify that, it would be the same as a 1 out of 8 chance of spinning. All right, let's look at another case. Again, we had probability of spinning a purple is 1 out of 6, and probability of spinning a blue is 3 out of 4. This one, though, they're talking about something different. This is mutually exclusive events, when two things cannot happen at the same time. So for example, spinning a, drawing an ace or drawing a 2 from a deck of cards are what's called mutually exclusive because they cannot both be the same thing. A card cannot be both an ace and a 2. These two groups are separate, aces and 2s. There's no overlap. Same with our spinner example here. There's no way to spin, spinning a purple and spinning a blue are two totally separate things from each other. They cannot be the same. So when we're doing a problem where they want to know what's the probability of spinning a purple or spinning a blue, okay, then when they're mutually exclusive, two events and A and B are separate, then the probability of spinning A or B occurs when you sum or add their probabilities together. So anytime you see or, that's an indication that you're going to add the probabilities together. You have an increased chance of something happening if you just need one or the other to happen. So in this case, we would take our probability of spinning a purple added with our probability of spinning a blue, because we only need one of the two to happen. Now, when you're adding fractions, remember you need a common denominator. So we need a common denominator between 6 and 4, which the easiest one would be 12. So if we multiply this by 2 over 2 and this one by 3 over 3, this would be the same as adding 2 twelfths plus 9 twelfths. So the answer would be 11 twelfths. We have an 11 out of 12 chance of spinning either a purple or a blue on these two. So the big thing to remember, and means to multiply, or means to add probabilities. Let's look at some other examples. Number 1, it says Julio reaches into an ice-filled cooler containing 8 regular soft drinks, 5 diet soft drinks. He removes the can, then decides he's not really thirsty, puts it back. what's the probability that Julio and the next person to reach in the cooler both randomly selected a regular soft drink? Okay, so we first want to find out what is the probability of drawing a regular soft drink. And for Julio, that would be 8 regular soft drinks out of, if we add 8 times, or add 8 and 5, there was 13 cans in the cooler. So 8 out of 13 chance. Now, because Julio's putting back the can, the probability of the second person is going to remain the same. So the second person also is going to be 8 out of 13. Now we have to look at what are they asking us. This is what is the probability that Julio and the next person to reach in the cooler both randomly selected. Remember, and is telling us they both need to happen. The probability chance is going to go down when you need two things to happen. This tells you to multiply. Anytime you see and, you want to multiply the probabilities together. So if we take 8 out of 13 times 8 out of 13, that would be the same as 64 out of 169. Or if you divide that out, it comes out to be about 37.9% chance. So and tells you to multiply. These are independent events. They're two things that the first selection, since we're putting it back, has no bearing on the second selection. All right, and number 2. Why don't you try this one out for tomorrow? See if you can come up with the answer for number 2 with the state lottery game here. All right, let's take a look at number 3. Number 3 says one teacher must be chosen to supervise a senior class fundraiser. There are 12 math teachers, 9 language arts teachers, 8 social studies, 10 science. If the teacher is chosen at random, what is the probability that teacher is either a language arts or a social studies teacher? This or word is going to be big as we go through this problem. All right, so first we got to figure out what is the probability that the person is a language arts teacher. So our successful events out of this one would be 9 language arts teachers out of, if we add up all the total teachers, it comes out to be 39 teachers. Okay. Next one, we got to figure out social studies. We have 8 social studies teachers. That makes us successful out of, again, 39 teachers. Okay. Or anytime or, it just has to be one or the other. We want to combine these together to find our probability. So this one, anytime you see or, remember that's an indication that we want to add anytime you see the word or. So this would be the sum of these two together. If you add these, we do have a common denominator already, so our chances are 17 out of 39 chance that it's social studies or language arts, or that if you divide it out comes out to be about 43.6%. So or is telling you to add. And since a language arts teacher cannot also be a social studies teacher, these are what's called mutually exclusive events. A language arts and social studies cannot be the same. All right, number 4 on the back. Says there are 7 girls, 6 boys on a junior class homecoming committee. A subcommittee of 4 people is chosen at random to decide the theme for the class float. What is the probability that the subcommittee will have at least 2 girls? All right, so these ones, you got to figure out, is it independent or mutually exclusive? These would be mutually exclusive events because you cannot be both a boy and a girl here. So so what we have to figure out is what's the probability that it will have at least 2 girls. Now, another way of thinking about this, if we are picking 4 people to be on the committee, this could mean one of a couple things. This could mean that we could end up having 2 girls on the committee, we could have 3 girls on the committee, or we could have all the way up to 4 people. So it could be all 4, the whole group is girls. So what we got to figure out to do this is it could be, or what at least means is it could be 2 girls, 3 girls, or 4 girls. It could be 2, 3, or 4 would make at least true. Or is telling us this is going to be an adding problem. So even though they didn't have the word or in there, we're going to need to add these probabilities. So what we have to figure out is what's the probability of there being 2 girls? What's the probability of there being 3 girls? And also, what is the probability of there being 4 girls? And we're going to have to add, when we're done, all these probabilities up because this is an or problem. All right. Well, there's something else that kind of implied with this. 4 girls is the whole committee, so we don't really have to worry about this last one. But 2 girls also means on the committee there's going to be 2 boys. And if there's 3 girls, that means there's going to be 1 boy on that committee as well. So we got to figure out what's the probability of picking these. So going through the problem here, then we want to find out what is this. Now, when they're picking these subcommittees, it doesn't say order is important. So these are going to end up being combination problem. So for 2 girls and 2 boys, we got to figure out what is the probability of drawing 2 girls. So we know there's 7 girls. We're choosing 2. We'd also have to find out how many ways to select the 2 boys. So with boys, it says there's 6 boys. We're choosing 2. On the bottom, we got to figure out how many ways of just selecting 4 people. So out of a total of 13, if you add 6 and 7, you get 13 people. We're choosing 4 of them. Okay, now we got to do the same thing with the next one. What's this next probability going to be? What's the chances of choosing out of 7 girls, 3 of them? And what's the ways we can choose out of 6 boys, 1 of them? Over again, the ways of choosing 4 people out of 13. The last one, what's the probability of choosing 4 girls? So that would be 7 girls choosing 4. We don't have to put anything with boys on this one because it'd be all girls. And then what's the probability again of out of 13 people choosing 4? So we got to go through and find some probabilities. Here you'd want to use your calculator again to do some of these combination problems out. Use your combination button. And if you go through and do this, you should be able to simplify it out. For time's sake, I'll kind of skip and do that part for you. On the first one, this should come out to be 315 on top out of 715. On the second one, that comes out to be 210 out of, again, 715. And on the last one, 560 out of 715. We're adding, since it's an OR problem, we got a common denominator here, so we can just add, I'm sorry, the last one's 35. This is a combinations one, so we can add all these up. And if you add them all up, you do get 560 out of 715. Now, if you can try to simplify, this one does simplify down to be 112 chances out of 143, or about a 78.3% chance. So, pretty good chance that at least 2 girls end up on this committee. All right, the last thing that we're going to just briefly talk about before tomorrow are what's called inclusive events and dependent events. Inclusive events are 2 events that are not mutually exclusive. For example, drawing a king or spade from a deck of cards. It's possible to draw a card that is both a king and a spade. So when you have inclusive events where one event could be both, you need to account for that. So let's look at this problem. If you wanted to find what's the probability of drawing a king or a spade, you got to find the probabilities. Well, king, we know there's 4 kings in the deck out of 52 cards, so that would be your probability of drawing a king. Or is telling us we're going to add. Spades is a suit. There's 13 cards in each suit. However, because there is one card that is both a king and a spade, what you have to do is subtract out that one card, because that king of spades is in both this group and this group. So that one card that's being counted twice, we need to subtract that one card out that is both a king and a spade. So the probability would be 17 minus 1 would be 16 out of 52 chances would be the probability of drawing a king or a spade. So if it's an or problem and there can be a something in both groups, that needs to get subtracted out. All right, we'll look at finishing your notes tomorrow.